Hello everyone, welcome once again to online course of structural geology in NPTEL. This is the last week and you already are familiar with the concept of strike line, stratum contour, plan views. So with help of those we will start a new series of problems, experimental problems, and that would be graphical problems. So, in the first problem we have a orientation of bed, and without the use of stereo net or stereographic projection techniques, just in a plain paper using our conventional biaxial diagram that we have learned through 11 and 12 and also in graduate studies, we will find out the plunge of two lineations on a bed whose orientation is known. The question reads as follows: a bed of sandstone strike 50° east of north and for dips 48° northwesterly. What will be the plunges of two lineation lying on the bed and trending due north and due west respectively? The scale of the problem is 1 centimeter is to 100 meter. So, now we have a blank paper, and in this blank paper the first thing we will do is that we will fix the coordinate system. So, our coordinate system will be conventional as we draw a biaxial xy diagram. So, this is our coordinate system, fixed coordinate system, and suppose we name the origin as O. Now, we know that the bed dips 50° from north towards east. Clearly, we have to fix the north. Conventionally, we fix the north as the top of this line. Now, we will calculate 50° from north towards east. We obtain a point and then we join this point with the origin. So, we will consider this line, suppose I name this line AB passing through the origin as the 0 meter strike line or stratum contour of the bed. Now, if this is a 0 meter strike or line or stratum contour of the bed, we draw the direction perpendicular to this line AB, and suppose I name this line OP. So, clearly OP is my direction of true dip. Now, I know the scale of the problem is 1 centimeter equals to 100 meters, and I also know the dip of my bed is 48°. So, clearly if I have to now find a point in the line OP, and then when I find the point I have to draw a line parallel to AB which will be another strike line or the stratum contour, and so from two strike lines or stratum contour clearly we will get the orientation of the bed. Now, to find out the point corresponding to the 100 meters strike line or stratum contour, we know that the dip of the bed is 48°. So, what we do is that we first draw a line over here. We now construct a subsidiary diagram where I draw this line. Now, I mark the 48°. So, in this diagram I join these two. I also know that the vertical separation is 100 meters if I want to draw the 100 meter strike line. So, now the 100 meters according to scale is basically 1 centimeter. So, what we do is that I rotate this thing entirely to draw this. So, clearly this corresponds to 100 meters. Now, if I draw a line parallel to this line, horizontal line from this 100 meters, it will clearly intersect the dip line which I have drawn, and then if I project the point I obtained in the dip line perpendicular to the horizontal line and parallel to the vertical line, I will obtain a point in the horizontal line. So, clearly the distance between this and the point I obtain will be my horizontal separation in plan view. So, we will do the task right now. So, what we will do is that we will first project the vertical 100 meters distance to the dip line. Now, what we will do is that I again rotate this thing for my convenience. Now, I again rotate to bring it to the original position. So, suppose this is my OP line, and clearly this point which I can call A dash. So, OA dash is the distance in the OP line to construct our 100 meter strike line or the stratum contour, because OA dash is the horizontal plane spacing of the 100 meter strike line. So, it is better to use a divider, as we do not have a divider in this case, we are taking the distance with the scale. So, now I will draw a line parallel to AB and passing through the point I obtained. Clearly, this N dash, I name these 2 points N dash and W dash. So, O N dash will be any lineation that is trending towards north, and O W dash will be any lineation that is trending towards west. Now, O N dash is the plane separation of that lineation, and we know that the distance between O N dash is 100 meters originally, because this line, if I represent it as CD, CD is the 100 meter strike line. So, now in order to find out the plunge of lineation that is trending north and containing in this bed, what we will do is that we will again construct a subsidiary diagram that I am doing below. And in that I will take the horizontal distance or the horizontal separation of O n dash, and that is around 1 point. Now, similarly, I construct the biaxial diagram. I know the vertical separation is 100 meters. So, O n dash is the plane spacing of any lineation content in the concerned plane and trending due north. Now, to find out the deep angle, we do a similar proceeding. For my convenience, I rotate this paper to draw the lines. and similarly I draw a line parallel to ON dash from the 100-meter point. Now, if I join the origin and the intersection of these two lines, then I will obtain another straight line which makes an angle with the horizontal, and clearly this angle will represent the plunge of the lineation contained in this constant bed and trending due north, because this is our plane separation and this is our vertical separation. So, when we project the plane and vertical separation and come to an point where the horizontal and the vertical separation meet. So, when we join that point with the origin, the angle it makes will clearly be the plunge. So, this is our plunge angle trending due north, and I measure it with a protractor, and the angle comes out to be around 36 degrees. In the similar process, we will find out the plunge of any lineation that trends due west. We will first take its horizontal separation or the plane separation to be precise, and then construct a subsidiary diagram. The plane separation is this is O, this is W dash, and then again we rotate the paper for our drawing convenience. And mark the vertical separation according to scale, which is 100 meters strike line. Now, we do the similar case, we just project or it is better to do the other way around. So, now, clearly I join O with our obtained point, and then again measure the angle with a conventional protractor. The angle comes out to be 34 degrees. So, for this problem, the plunge of lineation trending north content in this constant plane is 36 degree, and plunge of lineation trending west is 34 degrees. So, now we know that if we do not have a stereo net and have the orientation of a plane and two lineations contained within the plane, how to determine their plunge when we know their trends. And this process without constructing the geometrical attributes of a plane without help of a stereo net is called graphical problems.